With AWS Lambda, you can enable concurrency for the request that you want to provision. For this, AWS Lambda provides two types of concurrencies. One is reserved and the other one is provisioned. And we will discuss them one by one. And in AWS Lambda, in order to ensure that a function can always reach a certain level of concurrency, you can actually configure the function with reserved concurrencies. Okay, wait. You might ask me, what is concurrency? You have been talking about concurrency, but what it is? A good question. So before moving forward to reserve concurrency, let's talk about concurrency itself. So concurrency, I hope and I am requesting you to listen to this very carefully. Okay, so concurrency is the number of requests that your function is serving at any given time. I'll repeat that once again. Concurrency is the number of requests, or concurrencies are the number of requests that your function is serving at any given time. So Lambda has your function that you have written and uploaded, and if a single user makes a call to the function, it is considered to be a single request because it is a single call or single execution. So the number of requests that your function is serving at any given time, we consider that as concurrency. When you make a call and execute a Lambda function, AWS Lambda assigns or allocates an instance to it in order to process the request. And once the function execution finishes, it can handle another request. But wait, you have to understand that it's not like it can only process one request at a time. You can have a parallel request running on AWS Lambda, which in turn will incur more memory requirements and initialization of multiple resources. And just like any other service, AWS Lambda is also bound to quota. So if you see the table here, the default quota for the concurrent requests is 1000, and it can be increased to a huge amount by getting support from AWS. For function and layer storage, we have 75 GB default quota, and for ENI per VPC, or what we call as Elastic Network Interface per VPC, you can assign a maximum of 250 as per the default quota limits. I know you might be feeling really confused, but listen to this very carefully. For a moment, imagine concurrency values to be a pool of numbers. Okay, for example, let's take it as 100. And if 100 is the total pool value, then all 100, when not reserved, it's considered to be unreserved. And if you assign 50 out of them to the function, then that 50 becomes reserved. And the other one, yes, it is free and unreserved. And when a function has reserved concurrency, no other function can use that concurrency. And for the other functions in that account, they have to use the unreserved space or the unreserved concurrency. So now, as you have some kind of information regarding concurrency, let's move on. So as I have already told you, that concurrency is the number of requests that your function is serving at any given time. In order to ensure that a function can always reach a certain level of concurrency, we can actually configure the function with reserved concurrency. So as this term suggests as reserved, we must be clear that we are trying to reserve concurrency quota for a function for its efficiency or need. And with reserved concurrency, we have the following effects. One, where other functions can't prevent your functions from scaling, and the other one is that your function can't scale out of control because it has a limit on the concurrency to which it can scale. So if you see this image here, imagine the whole space to be a total concurrency, out of which the orange pattern that you see is the reserved concurrency. And the purple line that you see here is the throttling duration. By this, you can realize that when the function myFunctionDev throttles, it doesn't exceed the concurrency limits or the concurrency value. And the other functions which are running on the unreserved concurrency won't be able to prevent myFunctionDev from scaling. And only that function will be able to run with that reserved concurrency, as it's implied and that it has been reserved. So you might want to ask me, like, what are the problems and what could be the advantages of using reserved concurrency? So if you understand this concept very clearly, you have to comply that all the functions in the same region without reserved concurrency share the pool of unreserved concurrency. So let's suppose you have a limit of 10. Then the whole 10 represents the value of unreserved concurrency. Without reserved concurrency, other functions can use all of the available concurrency space. And this is a very bad thing because this will prevent your functions from scaling up when needed. On the other hand, if you feel your function will need this amount of traffic and it needs this space, you can provide it with reserved concurrency so that other functions don't interfere. Okay, so you have to be clear in your mind that you know that this function is going to need this amount of space. Ultimately, the problem might arise if most of the concurrency is reserved. Then the other pool of requests that you will have will face a higher latency if other functions take more time to set up and initialize. For example, there is a function that takes more time to initialize because the loading time of your function SDK and dependencies are higher. Other users who are trying to use the rest of the functions will face a lot of latency. And this is one of the main reasons why we have another type of concurrency in place, that is provision concurrency. So let's check that out. Next up, we have provision concurrency. You can enable provision concurrency for your Lambda functions for greater control over the performance of your serverless applications. That's what AWS tells us. And to mitigate the effects of reserved concurrency and to ensure that all requests are served by the initialized instances with very low latency, AWS Lambda provides us with provision concurrency. First, you need to understand that if there is a situation that arises that your functions need more power to handle increased concurrent executions and requests, you need to ensure that the users don't face low latency. And with reserved concurrency, it will surely limit your throttling if it exceeds your resource expansion. Then you will ask me how provision concurrency can help us with this. So listen to this very carefully. Lambda has a provision to integrate with application autoscaling. Yes, you heard it right. You can scale this service using application autoscaling. And you can manage autoscaling for provision concurrency by either of these options. So it can be based on scheduling, like you can schedule it to the scale when you need it, or you can scale it based on the utilization. The best thing is, for automated scaling, you can make use of the application autoscaling API to register a target and create a scaling policy. And you might have multiple questions to ask me, like how is it going to work? Will provision concurrency be set alone, or will it work along with reserved concurrency, or will it be both? And I would say yes, you are right. Provision concurrency counts towards a function's reserved concurrency and regional quotas. So it can be applied alongside the reserved concurrency that you have. And also it can be added up to the reserved concurrency of the function. And in this case, it will run all of the invocations in provision concurrency. So both of your questions are valid and the answers would be yes. So I hope it was clear. Let's check out the working principles here. If you see the example here, both the functions that you see here, my function dev and my function prod, both are running on provisioned concurrency and reserved concurrency. But the difference you can see is with my function dev. Okay, here my function dev is using the full pool of reserved concurrency and my function prod is with shared concurrency. And in the case of my function prod, the normal invocations are run with reserved concurrency, and in this case, if it needs additional throttling, it will run on provision concurrency. And on the other hand, the my function dev that you have here, all the invocations run on the provision concurrency. So you might ask me, I know you will ask me this in the comment section that, okay, you said all this, but what additional benefit we will get with this? And you also said that all invocations run on provision concurrency. How is that possible? And what is the advantage of it? Because it is taking all of the space of the reserved concurrency and it is adding up the provisional concurrency there. So what is the advantage there? Yes, I understand your question. So wait and let me answer them in the next interesting topic. So let's check functional scaling with provision concurrency. So to start off with this, I want to tell you that with provision concurrency, you get a burst so that your users don't face high latency. So let's clear this first. That answers your second question. What if all the invocations run on provision concurrency? Okay, so that is basically because of the burst. You will get the burst immediately. So then you will ask me what will happen if the provision capacity also reaches its limit. So in this case, as shown in the example here, when the concurrency hasn't reached the limit, so when it hasn't reached the limit, AWS provides a burst, and if that also reaches the limit, And if that also reaches the limit, it will scale up the function normally to handle any further requests. Okay, so with concurrency, you will have an initial burst of the traffic with regards to how much the function's cumulative concurrency in that region can reach. So at an initial level, it can reach from between 500 to 3000. And when the burst concurrency reaches its limit, the function starts to scale linearly. And if this concurrency isn't enough to serve all the requests, then additional requests are throttled and should be retired. But here as well, if your function still needs further throttling, then AWS tells us that we can provide you an auto scaling with provision capacity or provision concurrency as well. So yes, you heard it right. You can provide auto scaling to provision concurrency, as I have already mentioned before. In this case, what AWS means is that with application auto scaling, you can create a target tracking scaling policy that adjusts provision concurrency levels automatically based on the utilization matrix. So if you see in the example here as well, we see here that there is a range of minimum and maximum range of provision concurrency, and when the number of requests increases, autoscaling increases the provision concurrency in larger steps until it reaches the configured maximum concurrency. And when the request decreases, it moves on and lowers down the concurrency with smaller steps. So now let's talk about the pricing for provision concurrency. So we need to understand that provision concurrency is calculated from the time you enable it on your function until it is disabled, rounded up to the nearest 5 minutes. Because I've already explained how nearest to 100 millisecond means, so you can check the previous video for that. So now we will take an example here as well. So let's assume you have allocated 1024 MB to your function and enable provision concurrency on it for 2 hours. So understand this, you allocated 1024 MB to your function and enable provision concurrency for 2 hours. The concurrency that you configured was 1000. You executed the function 1.2 million times during the 2 hours and it ran for 1 second each time. So default values that you see here for provision concurrency for a particular region is 0.00, that is 5041667 for every GB second. I hope you understand GB seconds by now. And the request that we have is $0.20 per 1 million requests. And for duration, the charges are 0.00509722 for every GB second. Okay, for requests it is 0.20 and for duration it is 0.5097222 for every GB second. Okay, so now coming back. So the first thing is to calculate provision concurrency charges. So the provision concurrency price is 0.504167. Actually, we have rounded it up. Okay, for every GB second. And the total period of time for which provision concurrency is enabled in seconds is 2 hours. So 2 hours, when we convert it into seconds, is 7200 seconds. So then the total concurrency configured in GBs will be 1000 multiplied by, because 1000 actually is the term that we get, that the concurrency that you configured was 1000 multiplied by 1024 by 1024. So now the total concurrency configured will be in GBs, that is 1000 multiplied by 1024 MB, that is basically your allocated memory, by 1024 MB, that is basically we are trying to convert it into GB, so it will be 1000 GB. Okay, so total provision concurrency, which is amount to GB seconds, is basically your 1000 GB that you calculated here, total concurrency configured, multiplied by the number of seconds it has ran. So 1000 GB multiplied by 7200 seconds is 7.2 million GB seconds. Okay, so now provision concurrency charges will be 7.2 GB seconds multiplied by 0.504167. Okay, so this is the default provision value. Okay, and that comes around $30. And next we have to calculate the request charges. So the monthly request price is 0.20 per 1 million requests. Okay, and the monthly request charges will be now 1.2 million. That actually is the number of times it has run multiplied by 0.20. Okay, that is a charge. So you will get $0.24. Okay, so the compute price is 0.00, that's 509722 per GB seconds. And the total compute duration for seconds is 1.2 million into 1 second. So it ran 1.2 million times for 1 second each. So it becomes 1.2 million seconds. And the total compute GB seconds is 1.2 million seconds multiplied by 1024, that is the amount that is allocated by 1024, that is we are converting it to GB, so 1.2 million GB seconds. Now the total compute charges will be 1.2 million GB seconds multiplied by this value. This is what we get from the duration, which comes around $11.67. So now the total charges will be provision concurrency charges plus request charges plus compute charges. So the total price that we had for provision concurrency charges was $30, and now for the request charges we have 0.24, and for the compute charges we have 11.67. So total it comes around 41.91. So let's suppose you allocate 1024 MB to your function and enable provision concurrency on it for 2 hours. The concurrency that you configured was 1000. You executed the function 1.2 million times during the 2 hours and ran it for 1 second each. Then you will be charged for $41.91.